Today we're going to talk about functions and graphs. I wanted to give you a basic definition of what a function is. In the college algebra course, we're focused on kind of giving you information about a lot of different types of functions so that you can get a basic idea of how they work. So before we can kind of go down our laundry lists of different types of functions, we first have to sort of establish what a function is. Okay, so here's the definition that we'll start with. A function is a rule or correspondence. Let's stop there for a second. A rule would be like an equation. A correspondence would be like a pairing up of different numbers of different types. So, and then there's more. There's a criteria about how that equation or how that pairing works. So, a rule or correspondence that assigns to each element of one set, that would be all the set of x's or inputs, exactly one element of a second set, that would be all the y's or the outputs. So if we set it a different way, each x is paired with exactly one or only one y value, and that's the criteria for something to be a function. So a lot of times if you look in the textbook, a function is pictured as sort of a machine, right? So the idea is that when we make this pairing, a function is not able to make a choice, right? If we put an input or an x value into our function, it cannot choose between two y values, right? There is only one y value assigned to each input or each x. So one of the examples I like to give as an example of a function is the idea of a baby's age and a baby's weight, right? So if you think about when you're a parent, you take your baby into the doctor and the baby is weighed. So, and you take it in at various times, right? So when you take it in at 3 months, right, the doctor weighs the baby and it has a certain weight. When you take it in at 6 months, the doctor weighs the baby and it has a certain weight. At no point do you take your baby into the doctor and he, gives you two different values for the weight. For each age, there is only one weight. So that's the idea behind a function, right? For each x or each age of your baby, you are going to get one y value or one weight associated with that age. I like to draw this picture really just to give you some of the terminology that can be used for x and y. So x is sometimes called the input. We have a lot of freedom as far as what types of x values we want to put into our function, so it's also called the independent variable. We can choose it, so it's independent. And the set of all the x's together in one group is called the domain. Okay, so we take an x value, we plug it into our function, maybe it's an equation, maybe it's a table that we're referencing or a graph, and then from that function we get a y value or an output. The y value that we get depends on the x value that we started with. So if we chose a 2, we would get a certain y value. If we chose a 5, we might get a different y value. So for that reason, the y value is called the dependent variable. Y depends on x. And the set of all the y values together in a group are called the range. Okay, so then we spend a lot of time in college algebra talking about domain and range, and so I want to give you a little bit more specific definition for those two. And so here they are. So the domain is the set of all real number x values that produce real number y values. So I think a good example to kind of give you an idea of what this is talking about is the square root of x function. Right, so it's a function. For each x, I put into the square root, right? I take the square root of that number and I get one number out, right? So it is a function. But I cannot put all types of numbers into the square root, right? So what types of numbers can I plug into a square root? Think about that for a second. There are some convenient numbers, right? Usually I get students to say, you know, I plug in perfect squares. Perfect squares are convenient, right? 1, 4, 25, something like that. Okay, but I don't have to plug in perfect squares. I can take the square root of 5 with my calculator. So it doesn't have to be a perfect square. But can it be a negative? And the answer is no, right? So only positive numbers or 0. The square root of 0 is 0. You can check that out on your calculator. So for the domain, I can use any x that are 0 or greater. Anything positive would be another way to say that, or maybe technically non-negative. Okay, and we could use our interval notation to practice writing that in interval notation if we want. But that would be the set of x's that I could plug into my function. A real number x's that will give me a real number for y. Okay, and then the range would be the set of all the y values that I can possibly get out of this function. So if you think, I'll use the same example, you know, when I put in positive numbers for x, what kinds of numbers am I going to get out for y? Think about that for a second. If I have a positive number and I take the square root of it, I'm going to get a positive number for y. So the range for this function, all the possible outputs I can get, would be positive. Right? Greater than or equal to 0. And again, I could write that in interval notation, which we will do. Okay, so hopefully that gives you an introduction to what a function is, to the idea of domain and the idea of range. A second topic I thought would go along with this would be the idea of function notation. That word notation that we're seeing again just means a way to write something. So this is a way to write a function. So like we said already, we say that y depends on x, and so another way of saying that is y is a function of x. And so it becomes convenient to name the function that we're talking about so that we can sort of differentiate between two different functions, right? So, and a common name is f for a function. So we have this notation. This is the f of x. So we use the f of x just as a shorthand so that we can include all the important information. We can include what I'm using for my input, which function I'm plugging my input into, and what output I'm getting. And I can summarize that all in one statement. And that's the idea behind function notation. So we can use it in that way. We can also use f of x and y interchangeably. So if you see an equation with a y and you want to write it as a function, you can replace that y with f of x, g of x, some function name. Okay, so here's an example of that. Here's a function. This is an absolute value function, so that those bars there represent the absolute value, and here's the graph associated with that function. Okay, so notice I've used f of x here to write the function, but I can always change that to a y if I like y better. They're interchangeable, they're equivalent, they're the same. Okay, and so I can do a lot of things here with this function notation, right? I can plug values into my function for x. I can choose an x value, plug it in, and then calculate what the y value would be. I can make a plot of all of those points and create a graph, okay? As far as practicing the idea of function notation, usually you're given a question either with an equation or with a table or a graph that asks you to find, for example, find f of -2. So when you're asked that question, the -2 here is the x, and what you're being asked to find is the y. If you have an equation, trying to fit it all on one screen here. If you have an equation, you can plug that -2 in for x and calculate the y value. If you have a table, you can look at the table. Here's where x is -2, and I can quickly determine what the y value is. If you have a graph, You can look on your graph. Okay, here's the x-axis. If I go to where x is -2, and then I track either up or down, this time it's down from there, to the point on the graph, I can see that this point on the graph is -2, -1. And so the y value matched up with an x value of -2 would be -1, and I could figure that out. Okay, so every problem's a little bit different. Sometimes you're given a table, sometimes you're given only a graph, sometimes you're given an equation, right? So we'll just do one more of these. Here's f of 2. Since I've given you the equation, you could plug it in, or you could use the graph. I think the graph is a really fast way, right? So we look on the x-axis at +2. We track this time up to the place where we see a point on the graph. This is the point, 2, 3. So that 2 I'm being asked to find. When I'm asked for f of 2 equals what? 2 is the x value. And I want to list the y value, which is 3. Okay, and there are a couple more examples here you could fill in the same way. That gives you an idea of how function notation works. That's something that we're going to use off and on as well. So you just want to be comfortable with what it means. Notice that it is not some kind of multiplication, right? This is a notation or a way to write a function paired up with x's and y's. All right, well, we'll be continuing with part 2 in the next video. So good luck learning your functions, learning about the definition, and practicing function notation.